In this theorem, we looked at if a parallel line to one side of a triangle intersects the other two sides, then it divides those sides proportionally. So if we can look at what we have here, we have that segment, we have our two parallel lines. And so what that creates is that we have that BD here is proportional to DA, which is equal to BE here, which is proportional to EC here. And then this is just, if we look at this, this is the reciprocal of this, showing that if we start with this segment in proportion to this segment, that it is equal to this segment in proportion to that segment, which makes it a true proportion. Now let's look at the next slide and see how we would use this. So in this particular diagram, we are told that we have parallel lines here and here. And so what happens is that we are looking for then those sides to be proportional, and we have a part that is missing. So if we start here with this segment, which is 10, proportional to 15, and then match up this with this side here, which we don't know, which we can call BC or we can call it X, in proportion to this side here, which is 12. And so then we're just going to take and cross multiply and divide to find that that missing portion is 8. And now if we look at the converse of that theorem, if we were to see that we had sides that were proportional, so if we had side AD here proportional to BD right there, and then that equal to this segment proportional to this segment, then the converse is true, that these lines here must be parallel. The next slide we'll look at an example of how we can show that. So here we are asked if we have parallel lines, and so therefore for us to be able to say that they are, we have to be able to show that these sides are in proportion, that the ratios are equal. So if we look at what we have here, if we look at this 6 to 18, which is right here, and then the 8 to the 24, which is right here, that both of those reduce to that same ratio, which is 1/3, which tells us that yes, those two segments are parallel to each other. All right, in the triangle mid-segment theorem, we are told that if we have segment AD and equal to segment DB, which is right here, and then over here that we have segment AE, and it is congruent to equal to segment EC right here, then what we would know is that this line is parallel to this line, and then the relationship between this segment and this segment is right here, that segment DE would be equal to half of segment BC. And on the next slide we're going to look to see how we can use that. So if we're looking at this, we are told, you could see that we have this segment is 8 and this segment is 8. This is 9 and this is 9. So what that tells me is that the relationship I know between this and this is that if this side is 6, then this side must be half of that, and so that side is 3. And here's how we would work that out if we wanted to show the steps. but it's really just the relationship that we're making sure that we understand there. All right, so here we are told that if we have 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. So you can see that here in pink would be proportional to what we have in yellow, that's over here. And then here on this side that we have what is in blue to what is in green, and that is over here. And on the next slide, we're going to look at how we can use this information in a problem. All right, so in this problem, we have 3 parallel lines cut by 2 transversals, and we can see that what we can do is use these proportions. So we're told that this segment is 8, and so we have 8 over here, to this segment, which is 6, so we have 6 here, and then equal to 10, and then this is the segment we don't know, which is x right here. And so now if we take and cross multiply those and divide, we can see that the missing part is 7.5. All right, with this we are told that if we have 3 or more parallel lines and they cut off congruent segments on the transversal, then the segments on the other transversal must be congruent also. So if we are told here that this is congruent to this, then we would know that this is congruent to this. And on the next slide, we're going to look at how we would use that in a problem. So as we can see here, we are given, we have 1, 2, 3 parallel lines, and the transversals are being cut congruently. And so we see that we have this is congruent to this. And so I can set up an equation 3x minus 7 is equal to x plus 5. And so when I solve that equation, I get x is equal to 6. It only asks us to find x and y. I could put 6 back in there and find that that is 11, and as also that this would be 11. Over here on this side, we could take 9y minus 2, and that is congruent to 6y plus 4, and set up this equation here, which would give us 3y is equal to 6, which is y is equal to 2.